Okay, hello and welcome to this Getting Started with CyVerse webinar. I'm Jason Williams. Here we are in July, and this is a quarterly webinar that we give to give you an introduction to some of the technologies and services that are available to you through CyVerse. What I'm going to do is just give us a few slides to start with as a little bit of an introduction, and then I'll give you a few live demos that get you a chance to see some of the technologies, tools, and services that CyVerse offers to you. I'm going to give you a link towards the very beginning to the CyVerse Learning Center, where you'd be able to download or test out any of the tutorials, anything that you'd like to take a look at. And this entire presentation will be recorded. That recording will be available to you within the next few days, so that if there's anything that you missed or you want to cover in a little bit more detail, you could always come back to the video. You do have the options here in the Zoom technology that we're using to send me questions. And part of the reason why we do this live is so that we can take your questions live and go back and see anything that you would like to examine in closer detail. So with that said, I am going to go ahead and start sharing my presentation, and then we'll move into the live demos. So let me go ahead and start with that. And again, at any time, if you have a question, please feel free to use the chat features or the question and answer features that are available to you at the bottom there in the Zoom window. And I'm going to go ahead and share my entire desktop because we are going to make use of more than one thing. All right, excellent. And hold on one second. There we go. Excellent. Okay, so once again, thank you for joining. And the first few slides that I have prepared just give you a little bit of an introduction to what is CyVerse. We know that many of the people that join us and sign up for a new account do so because someone has told them that it's something they should check out. But this is a chance for someone who actually is involved in the project to give you a little bit of a personal introduction to the platform. One of the first things I'd suggest that you go ahead and take a look at, maybe even bookmark, is the CyVerse Learning Center, which is available to you at learning.CyVerse.org. Many of the tutorials and instructions that I'm going to be following along or giving you a little bit of an introduction to are residing there. They're constantly updated. So if there's any question you have, that's a place that you might want to look to first. Once again, that's learning.CyVerse.org. So let me step back 10,000 foot view onto the project and the vision for the project. We have more than 60,000, close to 70,000 users. There are petabytes of data that people are storing with us and sharing with us, hundreds of publications, courses, discoveries that have been enabled by CyVerse. But actually, the project started in 2008 as something called the iPlant Collaborative. That was when the first funding was announced, and it was explicitly for working with biological data concerned with plants at the time. 2010, the tools launched publicly, and the first renewal from NSF was in 2013. As we continued on, the mission broadened, and who we serviced was not limited to plants. So there was the name change to CyVerse in 2016, and our last round of funding was initiated just last year, about 1 year ago in 2018. So it's more than $100 million of NSF investment, but it's freely available to every member of the community. That even includes international users. We are your colleagues and we're your collaborators, and we're just as interested in promoting and doing the types of exciting science that you're doing. We just make this service available, and it's really an enablement service for anyone in the community to take advantage of. We do have a little link there. Just request that as people do make use of the services, please don't forget to cite them, because that's how people at NSF and elsewhere know that they're useful and should continue to be funded. The thing that CyVerse was built for is something called cyber infrastructure. I might have used that term once or twice, so let me just make sure I explain it just a little bit. When we think of cyber infrastructure, in some sense, it's things that you're already familiar with using: data storage, software, high performance computing, but also people who have knowledge and expertise. And it's really organizing those disparate elements into a system that really allows you to do what you'd like to do. The point of being able to use CyVerse, the point of putting all of these different pieces together, is that as you make use of the platform, you find it's really easy to move data where you need to move it, analyze data of the size and scale that you need to analyze it, and not worry about all of this sort of bits of piece of glue and tape and things that it would take if you're doing and putting these solutions together on your own. For some of us who have that technical expertise, building end-to-end pipelines might be part of the everyday routine. But for many of our users, most of whom are bench biologists, you don't want to worry about how do you get those pieces to fit. So in large scale, in large part, what CyVerse has done is put those together and make them work a lot more effectively. Some examples of what we provide you in CyVerse: platforms, tools and services, data sets. We're going to be seeing some of those things today. But underneath all of those things on the surface are actually a fairly sophisticated and fairly large amounts of computing and data storage. So actually, when you come to use CyVerse and make use of it, you don't have to worry about what your local resources are. You're not worried about what laptop you have. Everything is on the web as far as you're concerned, or we might even say in the cloud. So this is really fantastic, especially if you're an institution that you don't have those resources available to you. You can make use of them through CyVerse. The other thing we provide is training and support. Today's one example, but you can also see more information on the CyVerse website, and you might have questions about hosting a CyVerse workshop or just using the tutorials that I mentioned, and I'll allude to a little bit later. The other thing, take-home message that we want everyone to be aware of, is that CyVerse is built for data. So whether you're working with microbes, plants, animals, biomedical data, ecological data, or even different data types, everything from image data to genomics, really there are some CyVerse platforms and some CyVerse capabilities that have been built with those things in mind. This gives you a little bit of an overview of what we call the CyVerse product stack. So at the very bottom are the foundational infrastructure and systems and support that you might want to access. That's our cloud system, our HPC, our storage. In fact, if you really are a developer or a research software engineer, any of the people that are on the technical computer side, you can actually access these low-level services through APIs. But for most of us who are on the bench bio side, at the top layer of this, sort of layer cake are the services that I'll be demoing in this video and that you might be more familiar with. So web interfaces to bioinformatics tools, web interfaces to educational pipelines and to the cloud. These are types of things that most of us as biologists want to be able to consume without worrying too much about what's underneath. So what are some of the services and tools that are provided on the science side? Well, we tend to focus on genomics, not because that's the only thing that one can do with their science, but it's certainly one of the biggest drivers of large data sets and what a lot of our users, frankly, come to us for. So what you'll find when you come to use CyVerse are that many of the priorities that we've implemented are really what's been dictated to us by the community. So you'll find tools for genome assembly, for RNA-seq, for variant calling, looking at variation, for ChIP-seq, multiple sequence alignments, all those types of things. It's always a constantly evolving field, but CyVerse is really adaptable and flexible, so it gives you the power to follow where your science is going to take you. The other last take-home message, well, there's probably several of them, but one I want to make sure not to forget is that CyVerse really is a virtual collaborative organization. So currently the CyVerse project is made up of 3 institutions: the University of Arizona, Texas Advanced Computing Center, and also where I am at Cold Spring Harbor Laboratory. There are also other and growing CyVerse implementations. The largest of which and oldest of which, international one at least, is CyVerse UK, which also is between several different institutions. And they provide a number of parallel and complementary services that you have access to if you're in the outside of the US. Okay, so let's move in transition from a little bit of the history and background of the project to actually what are some of the products and services that CyVerse has developed and that you can use. We've always thought of our infrastructure as being modular, so Lego bricks are a really nice example or analogy. We built those pieces, we hope that they play well together, and we hope that we built 85, maybe even 95 of what you need, because there's always this last little bit that's custom, but even when it is custom, we made it fairly easy for you to be able to decide and design what is the way that you need your architecture to be laid out so that you can accomplish your analysis. Here are some of the major pieces. So the very first one is the CyVerse Datastore. Every user who signs up for their own CyVerse account is entitled to at least 100 gigabytes of data. If you need more than that, that's totally possible. We just oftentimes will request a little bit of justification, but it's still available to you at no direct cost. That large data allocation really allows you to store just about all of the files that are related to your research, and most importantly, really easily share those files, manage those files, and that'll be in the first demo that I give you a little bit of a peek into some of the essential features there. The next large piece of infrastructure is something called a discovery environment. What it is really a web interface to the tools and services of CyVerse. Many of the, I would say several hundred actually, bioinformatics tools, you can all use this point and click web interface. So if you're not an expert with the command line, you're not really comfortable doing that, you can actually take advantage of the CyVerse discovery environment where you can run almost any bioinformatics application. It's also extensible, so you can add your own applications if you don't see what you're looking for. One extension that's rather recent and we're really excited about is something called Vise, which is the visual interactive computing environment. And if you are familiar with or a fan of things like Jupyter or R or RStudio, we have a really nice solution that enables you to go from something like a Docker image to just going ahead and building and working with notebooks, R Markdown, etc. I'll talk a little bit about that and give a very short demo. We are also going to give a demo on Atmosphere. That'll be the demo that I conclude with, and that is access to our CyVerse cloud. CyVerse was one of the original and largest open science clouds, and it still exists today in the form of Atmosphere. There's even a parallel project, Jetstream. But it's really, really important, in my opinion, for scientists to realize that cloud is a really useful piece for a lot of the types of large-scale data-driven investigations that was required by many of our science projects today. And so I'll give you a little bit of an introduction on how to access that and decide how it might be useful or appropriate to your lab. There are several pieces of the CyVerse infrastructure which are important, which unfortunately I will not have time to demo, but I just want to allude to the fact that they're there and it's something you can explore later. Through the science APIs, you have access really to customize CyVerse as you see fit. This is something that would be appropriate for those of us who are developers and looking to use it more of a science as a service platform, where you can decide how you want to mix and match some of the capabilities that CyVerse makes available to you, but you do it programmatically via an API. DNA Subway is a tool that we built here at Cold Spring Harbor, and this is really fantastic for the classroom. Although I won't be giving a demo, it's very well documented on the CyVerse Learning Center and really helps you bring bioinformatics into classroom, which is a personal passion and pursuit of mine. You're able to give students access to the same tools and technologies that are used at research level and really prepare them for a life in biology, if they're certainly a biology student, that is going to be really computer literate, data literate. BISC is for image analysis and management. You can work with hundreds of image formats in a really scalable way. And there's also APIs available through BISC that really allows you to programmatically decide how you want to handle large image data sets. If you think about the importance of things like machine learning and image recognition, pattern recognition in those cases, that is a really fantastic combination and asset to what CyVerse provides you. Okay, so those are some of the really large pieces. Let me get even more practical by doing some demos. As I mentioned before, these demos are going to be available to you. We will record the entire presentation, and then you'd have an ability to go ahead and look at that later. What I am going to do is also, I'm going to switch back and forth between slides and also the presentation. And if you do have questions, I just want to remind you now that you can give me those questions anytime. One of the reasons we do it live is that we can interact with all of you who are online watching. So the first demo is going to be on getting data into CyVerse, because if you can't get your data into CyVerse, then none of these other things are going to matter. Okay, as I mentioned, the CyVerse Datastore is what we think of as our data repository. You can store any type of file related to your research, and we've worked hard to make sure that you can move those data very easily between one CyVerse platform and another. If you're working programmatically through one of our interfaces like ICommands, you can also access and manipulate and manage your data automatically if you like. And it really makes it easier to share those data with your lab, with your colleagues, and with the community. There are a number of ways to access it, really reflecting the variety of ways that our users need. We have some standalone programs, so Cyberduck is really one of the easiest and certainly highly recommended. It's a standalone GUI. We have the discovery environment, which I'll talk about more in the context not of uploading and downloading, but more management, metadata management, sharing. And then we also have ICommands, which is also a third-party standalone product, but one that you can install, and that makes it relatively easy to use it on your device, but using the command line. There are some advantages and disadvantages to using each one. I'll quickly cover them, but it's also well documented in detail on the Learning Center. As I mentioned, the discovery environment, the advantage or what excels at there is for data management and data sharing, so I'll show you that element. Cyberduck, you have drag and drop transfers of your files, so it's really almost like using Dropbox. And ICommands, if you're familiar with the command line, then you can go ahead and write scripts which will allow you to manage your data. Let me show you some of these in a very quick demo. Okay, before I go into the demo, I'm going to go ahead and load the CyVerse Learning Center at learning.cyverse.org. All of the documentation I'm referring to is here. And so if you're following along later or for sake of review, certainly you want to come to learning.cyverse.org. The instructions that I'm going to be following for the Datastore are here in the Datastore guide. So I just want to have that available. There's probably very little that I need to pull from here, but I just want to point out to you that all these things are here. The first thing I'll be talking about is Cyberduck, and the instructions in the Datastore go into the downloading of this free third-party software. The very first time you use it, you're going to download a configuration profile. I already have Cyberduck available and running. The reason why I have it running is because it takes about 20 seconds or so to start. But what you're seeing here in this Cyberduck window is actually my CyVerse Datastore. If I were to go ahead and do a new window or a new browser, you'll see that before you start it, you have a link that's created by that secondary download, that configuration profile. And then when you want to connect, you basically double click that. And within a few seconds, you'll have a window that looks like my connection here. Okay, I'm going to let that run in the background. But now that I can see the items in my CyVerse Datastore, if I want to transfer those items from CyVerse down to my computer, it's as simple as clicking on one of the files that interests me and downloading it or dragging it to where I want to download. So let's say I want to download it to my desktop. When I drag it over, I'll get this second window that shows me transfers and the status of those transfers. I could pause a transfer, I could restart a transfer that didn't work for some reason, etc. But there is where I have the ability to see what's going on. And doesn't take much to guess, but if you want to upload a file from your let's say your desktop or your laptop, as I'm on, into the CyVerse Datastore, you simply drag it to the window on the left-hand side, which is our CyVerse Datastore. On a really good internet connection, you should expect to be able to move about 100 gigabytes of data within 30 minutes or less. It depends upon your individual connection. The first few moments, as you see on my own screen, it takes a moment to actually do the authentication, which I unfortunately clicked the wrong thing and stopped, so I should restart it. There we go. Oh, and it wanted because of what I've done. Let's see if that's even right. It guessed my password. Okay, there we go. It takes a few moments for the authentication, but then it goes ahead at a pretty good clip. And so it downloaded this PDF file in this case. Okay, and moving the other way, you simply drag that and place it wherever you want it on the CyVerse Datastore. So I think that's fairly straightforward on how to use Cyberduck. You first need to download it, and the link's there at learning.cyverse. Once you've downloaded Cyberduck for your operating system, you'd also download this configuration profile. Configuration is a one-time thing, and then you simply follow the directions here. One thing to note as when importing any files in the Datastore, just avoid special characters and spaces if you can avoid it in your file names. Okay, so I'm going to show the the programmatic interface, the command line interface using something called ICommands, and then finally we'll end up in the CyVerse discovery environment where it's again all point and click for data management. There is a link here to command line transfers with iCommands, where you could search the CyVerse, learning.cyverse website to find this thing called iCommands. iCommands is available for Mac. Now that Windows has a bash kernel available to it, you would be able to install it on Windows if you're using bash, and also Linux. Okay, I already have iCommands installed, so I don't have to go through the configuration. That takes under a minute to go ahead and configure, but the very first time you're using, you'd follow the instructions here to use the initiation command and enter your credentials, and then you'd be able to log in. I'm going to go ahead and start a terminal on my screen. And let me just switch to a view that's a little bit high contrast. Okay. So if I want to go ahead and access the CyVerse data store, well, the first thing I might want to do is look at the files that are located in my own directory. So iCommands, you put an I in front of the command. We didn't come up with it, but we certainly use it. And as in Linux, if you want to list the contents, we'll do an ls. So if I do an ILS, what it's going to return to me is a listing of everything in my home directory. And the files that are here are essentially synonymous with the files that I saw just a moment ago in Cyberduck. If I want to move, or let's say I want to download some of these commands, some of these files, this documentation gives you an idea of the most common things that people may want to go ahead and download, and there's links to additional documentation to see more programs and parameters. But if I want to bring down a folder, let me just make some room here on my desktop so you can see it working. I can run a command called iget to download, and since I'm going to get a folder, I want it to be recursive, show me the progress, be verbose, and I can get the VCFs folder, so .vcfs, and I can download that to the desktop of my local computer. Enter. Since I hit verbose, it's going to give me some information about the status of the download. And as you can already see, although I am on a wireless connection, this is pretty small file size. On my desktop, there's a folder, and on my terminal there is an indication of what has been transferred and how long it took to transfer. So really, in a few seconds, it was able to go ahead and download that, and then I have the VCF folder on my desktop. That's what I was able to bring down. So if you are fairly familiar with the command line, then this is really no problem. Even if you haven't used the command line very much, there's some documentation there to help you, and it really is a very efficient way. Again, you can move 100 gigabytes of data in under half an hour. It's multi-threaded, and if you have scripts, you can take it, or you want to use scripts, you can certainly take advantage of the different commands like irsync. You can maintain maintain synchronization between a local repository of data and your repository of data on the CyVerse data store. Okay, so the last part of talking about data is talking about data management and metadata a little bit. So I'm going to go ahead and log into the CyVerse discovery environment. If I go back to learning that, well, actually, since I'm still in the transfer, I'll stay where I am and say data sharing. That's the next section here. But I'll just go ahead to the CyVerse homepage at CyVerse.org, just to give you an idea of where you can find these things. So from CyVerse.org, if you choose, products, or if you choose analyze, you'll eventually find a link to the CyVerse discovery environment. I already have it open, but I want to make sure that you know where you can find this. Okay, so this is the discovery environment, and you would click launch in order to access it. I've already got it open, so I might as well close this extra window. So the CyVerse discovery environment, which I'll talk more about in a moment for its data analysis feature, also serves as an easy place to manage data sharing and metadata. If I click on the data window, what I'll be presented with is a listing of the files that I have access to in my personal data store. On the left-hand side where it says navigation, I see my last name, which is also my CyVerse username, and that will give me access to my personal data folder. And then once again, I'll see all the files and folders that I saw a moment ago on Cyberduck, and also a moment after that on the command line. So these are listing in my files and folders. And what I'm going to show you is 2 easy ways to share those data. So that's really what I encourage and what many people have used the CyVerse discovery environment for as far as data management. So if I want to share an individual file, we have one quick trick that is just good to know. And this really works for individual files. It doesn't work for folders. But it is an easy way to share small data sets with anyone. They don't have to be CyVerse users. So it looks like I have a PowerPoint. And if I select that one, on the right-hand side, I can see a little bit more information about, when this was created, who owns it, etc. But if I just want to share it, I can go to the Share menu and say Create a public link. I can verify that that's the file that I want to create a link for. And if I click Create, what it will do is create a URL that you can give to anyone. So, in fact, probably I've done this more than once because I have more than one URL. If I click on that URL and just say show the link and copy to my clipboard, I can go here and actually open a new tab, just show you what anybody else would see. If they were to go, say you put that in an email, sent it to them, and enter that into a web browser, a dialog would open asking, do they want to go ahead and download this file, or open in my case, and they would be able to have access to it. So this is recommended for small files. You don't want to share really, really large data sets this way. We have better ways to do that, but it's really convenient. So I'm going to not download that. If I go back, I also have the ability to discontinue or to eliminate those links. So if I click the little delete icon next to every link, I can invalidate that link. And so if you think about sharing data securely, if I no longer want that data link to be available, when I click on it now, it's going to remind me that I can't access that. It doesn't exist for them. So it's just a nice and quick way to share data easily. However, what if I want to share really large data sets and I want to do so quickly? So this next method will work for not just individual files, but for entire collections of files. The caveat is that this method works only with other CyVerse users. So if you want to share a large data set with someone else, the recommendation is for them to also have a CyVerse account so that this will work. So I'm going to go ahead. This time I'll select a folder and I'll check select it. I get some information about the folder. But if I want to go ahead and share it, I go up to the Share menu, and this time I'm going to say Share with Collaborators. Now what I want to do is actually search for a person or persons who I want to share it with. So under Search for Users, I can type their actual name. And as soon as I start going into finding it, I should come up with their name if they have an account, as well as their institution. Now, the next thing I need to do is select the level of permission that I'd like to share it with. If I go back to the Learning Center, and I'm in this data sharing menu, it'll go through, I believe, towards the bottom, a little chart on what each of those permissions mean. If you are used to Linux and the Linux system of file sharing, then this will be fairly familiar to you. But read is the most restrictive. It just means that they have the ability to read the data. They can choose to download a copy if they wish. And own is the most permissive. You want to be careful about sharing data with the own level because that enables the person who you're sharing it with to rename it or even move it or delete it. And if that was your only copy or you need it to be in a certain place, then you might end up losing it. So be careful only to share own with whom you trust. Going back to the discovery environment, what I would need to do now, but what I'm not going to do since I pick on Cornell as my example every webinar, if I wanted to go through with this, I would click Done, and within a few seconds, he would have access to it. Since there's no data actual copying, but it's really sharing and altering the permissions, even a very large data set is essentially available instantaneously. So that pain of uploading a 1 terabyte data set only has to be gone through once. Once it's on CyVerse, then whomever you wish to share it with would have nearly instantaneous access. The way that you would be notified is up on the right-hand corner. There are notifications, and if somebody has shared something with you, you would get a notification that something has been shared with you. And you could review your notifications. If I go back to see all of my notifications, I can go through and see the last time something has been shared with me. I think I need to go off this page where I'm just selecting only new ones right now. I could go and see all of them. In fact, actually, I could sort and just say data, and then I could see something has been shared with somebody or something has been shared with me, so you get an idea of those things. And then you would click on that notification and it would directly navigate to where those data are located after having been shared. If I go to the shared with me folder, which is on the left-hand side of the data window, I will also see a collection of usernames, and those usernames are linked to whatever data sets those individuals have shared with me. If this is your first time using CyVerse, you'll still see some usernames because there's some things that are shared with everybody on the system, and so you'd see it there. The last thing that I want to mention that I don't have all that much time to go into, and so I'll just have to refer you to looking at it on the CyVerse. Let me just zoom out here. I'll just have to refer you to listen to seeing it on the CyVerse, learning.cyverse.org, is the capability here for metadata. So of course I can search for files, but if I go to metadata, or rather if I go, let's go here to my personal home folder and click on the search icon, I have advanced search parameters. You see every item in the CyVerse data store can actually be marked up with metadata. So if I go ahead and say I want to find a file name, or even if I looked at it and I say I want to find by metadata that is and has the value genus, I can see anything that has been marked up with a genus. And if I go ahead and search for this, what it will do is find anything that has the attribute genus as part of what that is. And if I go look, these are really simple examples that I just sort of create for demos. If I view the metadata of that file, okay, I need to actually go there to additional metadata. I could see that it has this value. If I wanted to, I could also adjust, or I could add metadata to this. So I could say I want to add a new attribute, and this attribute could be anything that I want. I can edit it and say that it's, you know, experiment line point, and I could say the value is 1 and the unit is hour, and I can go from there. If I did that, you know, now I'd be able to search and I'd say, give me everything that has an experimental time point, so on and so forth. You get fairly sophisticated. You probably wouldn't want to enter metadata manually as I did very often. We do provide templates, and you can also upload common separated value tables, set spreadsheets, along with your data sets, and do really some fantastic things. To learn more about that, since I don't have time to go into all of that right now, unfortunately, there are some information there on associating data with your metadata. It's one of the services that we use, for example, for submission to NCBI, because you need to mark up your files first, and then you can send everything off as a package to deposit your data in the SRA, and there's a tutorial that goes into that as well. Okay, the next thing I need to spend just a moment on is actually analyzing your data with CyVerse. I have a couple slides to orient us, and then we'll continue from there. We're still going to be in the discovery environment. Okay, so as mentioned, the discovery environment is a platform, and you can run almost any type of bioinformatics applications. It's integrated with the high performance computing and with all of our computing resources, as well as the data store, and it's extensible. Although I won't show it to you today, you can go ahead and integrate your own applications. We've already seen the data window, and that's where you go to upload and download. You can actually do the upload and download of small files and folders. You can share, and that's what I focused on, and you can also work with metadata. We're going to talk about applications, including Vise, but essentially from here you can run any of the applications that have been integrated. You can modify apps. There's some workflow creation tools. And in analyses, you have a history of what you've done. This is really important, especially when you're working with a graphical interface. It may be difficult to communicate to others what steps you followed, or even to yourself, because it's not a command line where I'm used to at least looking at line by line what commands you've done in a script. But we do have that ability to check and see and examine the history of any analysis that you've watched. What we're going to do in this really quick demo is we're going to just take some unaligned DNA sequences and align them into a multiple sequence alignment using a program called Muscle. It's fairly straightforward and quick, so it makes a nice demo of the capabilities. And once you understand this, you essentially understand how to use any of the tools there. Okay, we'll come back to Vise in just a moment. Okay, so the information for this, if I go to the Learning Center home, and anybody who is following along, you'd be able to see this in the Discovery Environment Guide. So essentially all of the instructions that I'm following in this walkthrough are covered here in detail. Okay, so what I would want to do right now, first let me take a look at the data, just so you see this. In data and community data, just want to show you the data set that we're going to be using as an example. And if I recall, this is going to be in CyVerse training. And let's see, I think it's going to be in platform guide. Let's see if I remember all the right place. I'll need it in a moment, so good that I find it. And we're looking at the discovery environment. And this is the muscle sample that we're going to be looking at. So muscle 3.381. This is not the actual software. It's just the input file that I'm using to give the demonstration of. So if we look at it, I said we're going to take some unaligned DNA sequences in FASTA format. And what we have in this directory here are some unaligned sequences in FASTA format. So if I click on that, it's a text file. So it'll go ahead and open up and I can just sort of preview it. So I just wanted to make the case that here is what we're starting with. And give a second to load since I am on a wireless connection. Okay, here are our files. Okay, I don't need that, didn't need to do that, but I just wanted to show that it exists. Okay, what I want to focus on are the applications. So I'm going to go ahead and click on apps. And if I look in applications, there are lots of applications. Let me actually make that window a little bit bigger. And I could search for them by topic. I could search for them by operation. What I'm going to do now is simply just go in the search bar and search for muscle. Make this a little bit bigger. And the muscle that I want to use is this muscle 3.8.31. All of the applications have these sort of little buttons associated with them. If I click on any of those three dots, there's an app info button. That gives me a little bit of background on the app. There may be a link there to a manual, user manual. I might see if other people have rated the app, how many people have used it, and when's the last time it's been used. These are important to me because I want to make sure that since these applications are applications that are often integrated by community members, you want to take stock of, is it working properly? So all of those things are there for you. In order to actually use the app, I click on the app name. When I click on the app name and I just minimize that other window, I get a window that looks like this. And basically all of the tools within the CyVerse discovery environment looks something like this. It's this sort of accordion menu as you go through the different steps of filling out the inputs or the parameters for the application. But even if you take an application that you used before, the command line, muscle is a command line application. Callisto, HiSat, these aligners would be command line applications. Essentially, they've been integrated here so that they're point and click rather than working on the command line. I can leave comments, which I always encourage. So this is a demo. The output folder is where by default my results will go. By default, it's a folder that's called analyses. You could change that. If I had a folder called Williams Lab folder, I might want to change the default in my personal preferences so that me and other folks in my lab, as we use the system, we make sure that they output to the same place. As I go through, I see there's this accordion menu. So the next thing is called select input data. So if I click on browse, it's going to go ahead and browse, and it will browse to the last location that you had selected a file from. So in my case, I need to go back to this CyVerse training and platform guides, discovery environment, muscle 3.81, and muscle. Okay, once I navigate there, that DE sample plants is my input. Pardon me. I'm going to say okay to that. The next thing is also required, as I can tell by the red star. So I move down and it says sequence type. And as we saw, that's DNA, so I'm going to go ahead and send it's DNA. Now, the only thing I need to do is click on Launch Analysis. I'll get a notification at the top that my analysis has been launched. Okay. So it's there. It's also notifications. I can see what's going on. And I could see that it goes through various steps. So it goes through submitted, then the application will run, and then hopefully you'll get back that the application is completed successfully. There's always a chance you get a fail, and then you can go through the process of debugging and see what's going on. Okay, what I'm going to go ahead and do is click on Analyses. And Analyses gives me a history of everything that I have been analyzing using the Discovery environment, and also the current status. So I could see that this muscle 3.8.31 is in the status running. And what I will do when I'm done is I'll click back here to see the results. If I click on any particular job, there are also some other options. So if I go to the Analyses menu and I were to click on View Parameters, I actually can see the actual parameters that I used previously. This is super important. If I'm using a click and point GUI and I click a bunch of buttons and it kind of gives me what I'm looking for, unless I meticulously wrote down all of the things that I chose, I might have a difficult time reconstructing it. Here, I see all those parameters and I can save them if I wish to a simple text file. So it makes it a lot easier to be able to reconstruct what you did. Up in the analysis menu, if I wanted to relaunch this analysis and have it come out with exactly the same output or inputs that I was launching with at this time, I could go to Analyses and click on Relaunch, and it would open up that window again that I saw just a moment ago. The difference is it would already be pre-populated with the selections that I made last time. This is really helpful if I'm using an application that has multiple parameters to adjust. I wouldn't have to go through and redo each one of those. There are also options here for canceling analysis or stopping something if I know that something has gone wrong. Okay, so that's going to run for a few more seconds. But while actually it says it's completed, so I can go ahead and click on refresh. Okay, now that it's at the status complete, if I go ahead and click on the name of that, it's going to navigate to the output, which is going to be my analysis folder, plus it's going to be one level deep in a custom folder that was created when I launched this job. But it will navigate there, and then what I expect to see are my outputs. Okay, and here are, for example, an interleaved file. And this should be my interleaved formatted multiple sequence alignment from that original unaligned file. So give it a second to load. And there it is, okay? So that is what I was expecting. Okay, so hopefully that gives you a little bit of an idea, although we used a very simple application. Essentially, you can go ahead through the apps list and search for what you're looking for. Although I don't have time to go into today, if you don't find the application you're looking for, there are ways for you either to install it yourself or to ask for help. In fact, I should mention, if you get stuck with something, you often see this round button at the bottom of many of our platforms, and this is the chat help system. So that's often the very best way to contact us for help. Someone can answer you if you're during the hours where we have live chat available. If not, you can go ahead and leave your message and then someone will follow up with you. But it creates a support ticket, so it's a really wonderful way for us to be able to help you if you experience an issue. I'm going to close that for now. The last thing I want to show you in the discovery environment is really quick look at this thing called Vise. What I'm going to do is I'm going to just launch an application so that since it takes a few seconds to launch, I can just introduce it and come back to it once it's done. So I'm going to search for Jupyter Lab instance that's available. And I'm going to go ahead and click on this and just launch it. Okay, that'll be available to me in a few moments. So Vise stands for this thing called Visual Interactive Computing Environment. And if you're familiar with a lot of the tools of data science, things like working with Jupyter Notebooks, RStudio, RMarkdown, RShiny, these are some really common tools, not exclusive, not all of the possible tools in the data scientist toolkit, but certainly one of the more popular ones. I unfortunately don't have time to explain very much about Jupyter and RStudio. I'm very big fans. But if you do know what they are and are looking for a way to use them in your workflows, then this is really the tool for you. There are a number of options that we provide that make this a pretty attractive way to host and use these notebooks. We don't have explicit restrictions on the data limits. We have really a very secure environment that can provide, so everything's behind our authorization authentication. You can actually create that custom environment. So if you're a developer, you can actually go ahead and set up what you'd like to do in a Docker file and then point us at that Docker file. So you can really customize how we deliver and deploy the RStudio or the Jupyter instance. They're longer runtimes, so everything by default is about a 48-hour runtime, but you can log in and extend that. It scales well, and you're able to share those apps analyses. So this is really all in the vein of what we call reproducible science. For Jupyter, this interactive system is really a way to display many languages, not just Python, in the form of these notebooks, which combine narrative along with codes. It's a really popular way to present workflows nowadays. RStudio is really the most popular integrated development environment for working with the R language. And again, if you know about it, needs no explanation. If you don't know about it, I encourage you to check it out. But it's a really nice way, custom way of working with your data set. And you, again, can handle all of this within the CyVerse discovery environment. Now, of course, many of these things you can set up on your own laptop. But again, it's putting it on top of a layer where you have access to really large compute and large data storage that makes it easy. And if you distribute your notebook through CyVerse, in that way, it makes it easier for other people to reproduce. So what I did was I launched essentially a very shell of a Jupyter Lab instance. There's not very many tools installed on it, but it does work. So if I go back here, the discovery environment, I do have a notification a link to my Jupyter analysis. And it usually takes under a minute to load when I started it from CyVerse, but basically it's here, it's available, and I'm running Jupyter now. I'm inside my own private container. This is not explicitly connected to the CyVerse data store, so we do have a plugin on the left-hand side. You could go ahead and follow the methods there to go ahead and connect and to move this up into your CyVerse data store. But as you're working with different notebooks from home, close this, you can go ahead and start an IPython notebook, and then anything that you would express, whether you'd say, this is text for something that's going to be a markdown cell, or go ahead and add a code cell and print something. You get the idea that if you're used to working with these environments, you can go ahead and make these environments work for you. You can upload your notebooks and then make them available through CyVerse. Really, it's one of those technologies where if you are familiar with it, as I am, it's super exciting to be able to deliver, and for me personally to teach this way, because this is a really nice way to make use of the interactivity that notebooks and tools like RStudio or RShiny provide you. Okay. And of course, I would take more questions about that. If you have it, remind you at any time you have questions, go ahead and submit them. Otherwise, refer you back to the CyVerse Learning Center. All right, so we have time for one last demo. We're nearly at the top of the hour here. So let me orient you with some slides, and then we'll present that very last demo in Atmosphere. Okay. So Atmosphere is our cloud environment. It gives you access to hundreds of virtual machine images. If you're not familiar with what that means, I'll explain just a little bit in a second. It really allows you to customize your software setup, and it's integrated with our other computing and data resources. If you're not so familiar with cloud computing, well, you probably use it every day, although you may not have known you're using it. But let me give you a little analogy to explain two important pieces of terminology that you need to understand. The first one is something called an image. What is an image? And the second one is an instance. What is an instance? So this analogy starts out with a computer. Let's say that you bought a new computer and you want to take everything from your old computer, all your data, and move it onto the new computer. One way to do that is you could go ahead and copy those documents and files onto a hard drive, external hard drive, and now you have a backup. But another way is to actually clone the entire machine into one file. And this file would be called an image file. It's still a file, but it actually has a lot more than just individual documents or individual photos or individual high throughput sequencing reads. It contains your operating system. It contains the parameters. It contains the cat photo that's on your desktop. When you take documents and files off of a backup hard drive, there's still those original documents and files. But if you take an image file, now you've got everything, a complete clone of your original system. There would be no reason to reinstall software. It's already been installed. So it really is a convenient and portable way to recreate an entire computing system. If we're talking about reproducible science, then essentially it means that if somebody creates a virtual machine image, you know when you're using that, you're using exactly the same setup, down to the drivers, down to all sorts of dependencies they used. Next term is something called instance. In the CyVerse cloud, we have physically hard drives, CPUs, RAM, and when you're using the cloud or Atmosphere, you're asking us for an allocation of that. So we give you that allocation, and you also need an image because in order to build this virtual computer, you need an operating system. The image often will be something that's been customized by somebody else to have the scientific software that they'd like installed, but you can also make your own images, and that way, every time you launch it, it's exactly the same setup you left it with. But once you take that allocation and you launch it, then you have what's called an instance, and that is what will be available to you as a user at an IP address. So you go into Atmosphere, you choose that you want, and within about 15 minutes, you have access to it. Let me show you how that works in a very short demo. You could access Atmosphere from the CyVerse homepage. Once you're in, it looks something like this, where you see a desktop of your history. If I go ahead and say click Launch New Instance, what it will do is come up with a catalog of the images. I could search, for example, if I wanted to do, let's say, RNA-seq, I could just start typing in the term like RNA and see what's available. So here, somebody has some tools. You could click on any individual one of them to see what's involved or what's there. So they've got Salmon, Trinity, Multi-QC. Maybe that's something I needed. But the idea is you don't have to install these things yourself. If I go ahead and, well, actually what I'll do is I'll start with an image that basically has nothing. If I want to launch this Ubuntu image, I click on it, and then I say, okay, I'll go ahead and launch it. Then I choose the size. You have up to 128 gigabyte RAM, 1200 gigabyte of hard disk space, and 16 CPUs. I'm just going to launch something small, and then I would say launch instance. Atmosphere is not by default included in your CyVerse account. You need to request access from it, and when you log into CyVerse Atmosphere, you'll be prompted to request access to it. It's freely available to users in the US. If you're using it internationally, there are some restrictions, so we could let you know about those. Also pays to register with an .edu or .org address in order to access CyVerse, so that's associated with your account setup. So that'll take a few seconds to launch. I've already launched something in the back end, which I can connect to, and I'll show you how simple that is. Let me go ahead and while that's launching, just go ahead and open up a new window. Of course, now I feel it's going to be already there. So I'll go to my projects, and in my demo project, I have something that's running. Once something is running for you, it'll appear with an IP address, and the status will be green, meaning it's active and it's ready to connect. If I click on it, I'll see some additional information. And if I want to actually access it, the easiest way is to do something like this. Click on Open Web Shell. And what it's going to do is going to connect over the web to a virtual terminal. If you're used to using a terminal, then you will actually see something that looks like this. And I could, do an LS to see what's around and use it as I would any computer. This happens to be using it at the command line. If you use it for the very first time or the very first time you connect, there are some instructions to connect this to the CyVerse Datastore, and then you can move data between your instance and the CyVerse Datastore seamlessly. If I go back, if I actually close this tab and want to use, this one happens to have a desktop, and if I click on Open Web Desktop, it'll go ahead and connect, and it's just like using a virtual computer. It didn't exist a few moments ago, but now it's there, and I could do anything with this as I would with a normal desktop computer. These all happen to be running Linux. Of course, also, I could connect to this using my terminal, again, from my local laptop. So once I have the IP address, I could just copy that. And if I start a terminal, this one I'll leave with that background, with SSH into it. Oh, and this particular one, I've used this before, so let me just edit this. Oops. Okay, you would not necessarily have to do that, but I just wanted to fix that so I could connect. Now I'm connected to that atmosphere thing. And I can create a folder on my desktop that I'm viewing on the left-hand side there. There's my Hello World folder. So you're seamlessly connected. There are a number of other things that you want to think about when using Atmosphere. Of course, at the Learning Center home, there is the Atmosphere guide that goes into instructions for using it. But in any case, when you're using Atmosphere, this is a finite resource, so you have a number of hours that you're allocated every month. You can always request more if you need more. When you're not using it, if you're just stepping away for a while, you might want to shelve that instance or suspend it. And if you are really totally done using it, then you can delete the instance. You do have to be careful because once you click delete, there's nothing that we can do to recover that data for you. But those things are fairly well explained in the Atmosphere guide and documentation that you'll find. So we're nearly at time. This has gone very quickly for me, at least. Let me just check to see if we have any other things we need to cover. The key thing here is to re-emphasize going to the CyVerse Learning Center because there are getting started guides, there's tutorials, there's other additional documentation. Also, if you check on our website, you can see upcoming events like workshops and webinars. I definitely recommend that you check that out because you can also request a workshop or you can contact me. If you registered for this webinar, probably you should have my contact information in order to inquire further about that. So we want to thank all of the CyVerse team that definitely made this happen. And what I will do is pause here to see if there are any questions that folks have for me in the last few seconds of time that we have left. If there are no questions, then what I want to do is thank you for spending your time with us over the past hour. There'll be a notification when this is posted to YouTube, and then you'll be able to follow along then. So with that, I don't see any questions. I see I'm getting a few thank yous, so thank you very much for those who attended. And with that said, I want to thank you for signing up for a CyVerse account. Hopefully, we want to certainly afford you the best experience possible, so give us some feedback. And hopefully, I personally get a chance to see it work with some of you in the future. It's always a pleasure to run into our users at conferences and meetings and workshops. So thanks you once again for signing up for your account, and we wish you the best using CyVerse to accomplish your science and education goals. I'll end the meeting, and we'll see you next time.